Already we are late in the class, by the way. Okay. So today is your
Yes, sir.
backup class for the chapter materials, metals and non-metals. Okay. Hope I am properly audible to you.
Yes, sir.
Hmm. All right. By the way, your exam is almost 10 days away, right? It's on
Um,
11th, yeah,
it's on 10th.
10th of June, right? Okay.
Yes.
Okay. So this chapter was left to be done. Right now, cell structure and function, we have discussed that chapter, and this chapter is left to discuss. Okay. Apart from this chapter, is there any other chapters that is left?
No, sir.
No. Okay, then let us start this chapter and let us see if we can cover this today. We will try to finish the chapter today, but the chapter is a little bit lengthy, so we might require two classes. I'm not very sure, but we might need two classes. Okay, now.
Okay, sir.
Anyways, let us begin the chapter. That is materials, metals, and non-metals. See, uh, before we start this chapter, there are a few basic things you need to understand. Like a substance which cannot be broken down into two or more simpler substances. There are substances which cannot be broken down into two or more simpler substances by some chemical reactions, like by applying heat, by light or electricity. That is called as an element. So in the chapter, first of all, you need to understand about element. Have you heard of this term before? Element?
Yes, sir.
Good. In nature, we have got around more than 118 elements are found in the nature. About how many?
More.
118.
Yes, sir.
Right now, and they all are represented in the form of a periodic table. There was a person called as Mendeleev. Dmitry Mendeleev, he gave the modern periodic table. Right now, although there were so many scientists that came before Mendeleev who also attempted to arrange the orders in a proper manner. Right now, but right now, as of today, we follow the periodic table given by Dmitry Mendeleev. So in this, you will find more than 118 elements are there. Like hydrogen is there, helium, lithium, beryllium, boron, carbon, nitrogen. So this element, which moments ago I was defining this element actually. What are basically elements? Elements, these things that you see over here, like hydrogen, helium, lithium, beryllium, etc. These are the substances which cannot be broken down into two or more simpler substances via some chemical reactions, either by applying heat or light or electricity. For example, let's talk about, let's talk about iron. If you were to talk about iron, or you were to talk about any other element in this periodic table, it's an element because it cannot be broken down into two or more simpler substances by the usual methods of carrying out chemical reactions, such as applying heat, light, or electricity. One needs to note down that elements themselves are the simplest substances in the nature. So, since they are the simplest substances in the nature, thereby they cannot be broken down or split up into any more simpler substances. Try to understand this. So we have several examples of elements. All these are the symbols of different elements. Like in the periodic table, it's not possible to write the whole word for the element, so they are written in the short form by the way. Right now, and every element you can see it is being represented by their respective symbols. Right, and no two elements can have the same symbol. So basically, a symbol is the short way to write an element. Getting it now? Furthermore, if you were to look at hydrogen, or for example, look at sodium, if you were to take the smallest particle of this element, smallest particle of Na basically refers for sodium. The symbol for sodium is capital N and small a. Getting it now, Gauri? So the
Yes, sir.
smallest particle of this element, of this, say for example, sodium, is an atom. Right now. So atom is the smallest particle of an element, right? And a sample of an element will consist of only one kind of atom. If you are having a sodium, then in sodium you will only find atoms of sodium. You have iron, for example, you have iron. Iron is represented by the symbol capital F and a small e. In this, you will be only have iron atoms. Getting it now? Okay, now. So
Sir.
element which we are talking about right now, it's a substance. We can say that it's a substance which is made up of only one kind of atoms, and there are going to be as many kind of atoms as many elements are there in the nature. If there are 118 elements in the nature, so there are going to be 118 different types of atoms. Are you getting it? What I'm trying to say?
Yes, sir.
Actually getting it, or just agreeing to what I'm saying?
Getting, sir.
Getting it now? Okay. So similarly, we can talk about sulfur or phosphorus. Every will be made up of same type of atoms. That is the thing. Also, the atoms of any element, it will remain unchanged. It will remain unaffected by the physical changes in the element. Meaning that, say that you were to have an iron rod. This iron rod is made up of which element?
Iron.
Iron, obviously. Say if there is some physical change in the iron element. Say that if I were to break it into pieces, so thereby due to the change, due to this physical change, the atoms are not going to change. Getting it now? The atoms of an element remain unaffected by the physical change in the element. You break it into pieces, it will still have the same atom in it. It's not like the atom will change to sulfur now. That's not going to happen. Right now?
Yes, sir.
Okay, now. Okay. Further, you get to see that every element will be different from each other. Yeah. Like iron is going to be different from calcium, from manganese, from cobalt, from nickel, uh, or from oxygen. So every element is different because their atoms are different. Okay, now. Further, presently there are 92 naturally occurring elements. In the periodic table, we find that out of 118, 92 of them are naturally occurring. Getting it? What I'm trying to say?
Yes,
Okay.
sir.
So some of them are naturally occurring, while the rest are prepared in the laboratory. So in the nature, we have got 92 naturally occurring elements, while the remaining are prepared in laboratory. Hope it is clear to you. Okay.
Yes, sir.
This was one of the basic things you need to know about this. Then let us understand about metals and non-metals. Here in this image, you can see the ones that are shaded into the blue color. They all are metals. Okay, now the one that is in blue color, they are all metals. And if you count them, you will find that out of 118, 93 of them is metals. 93 of them are metals. All right now?
Yes, sir.
Okay, hope you are getting it. While in this, even in this, you get to find that now some of the metals would be occurring naturally, while some of them will be artificially produced. So some metals are artificially produced also. So keep that thing also in your mind. Okay. While the one that are yellow shown by the yellow color like boron, carbon, nitrogen, oxygen, fluorine, neon or helium, silicon, phosphorus, sulfur, chlorine, argon, etc. All of them are non-metals. So the keep one basic thing in mind, that why one element is different from another element is because their atoms are different from each other. Because their atoms are different from each other. So that is one of the main reason why two elements can never be same. Hope that much is clear.
Yes, sir.
Further, let us understand about the properties of metals and non-metals. Generally, in the first image, these are some of the general examples of metals that you can see on a daily basis. You have iron, you have copper pipes, you have iron pins, iron sheets, right? Iron tracks. You can have gold, you can have silver. All of these are the common examples of metals. In the second image, you have phosphorus, for example. You have phosphorus. You have, I mean to say, you have sulfur. The second image is that of sulfur. Getting it? So you can have different examples of metals and non-metals. In the chapter, basically, what our aim is, we are basically going to learn about the properties of metals and what are the properties of non-metals and how they are different from each other. Hmm. How a metal would be reacting with oxygen, how a non-metal would be reacting with oxygen, how a metal and a non-metal would be reacting with water, with acids, and with bases, etc. Right now, so that is our aim in the chapter. So first of all, we are going to learn about the physical properties of the metals. Right now, what are physical properties of the metals? Right now, let us learn about physical properties of metals. First thing we get to know that metals are going to be sonorous. Like you go to a temple and you ring this bell, it will produce a sound. Right now, so metals are said to be producing sound. Right. Further, metals can be beaten into thin sheets. Metal can be beaten into thin sheets, so they are called as malleable. That is, they can be heated and beaten into thin sheets. Thereby, you can make copper, you can make plates out of metals, you can make sheets out of metals, and then you can heat the metals to draw them into wires. Like you have copper wire, even gold wires are also there. And the most useful property about the metals is that metals are hard. Metals are tough and strong.
Hard.
Right. Good. But the metals are going to remain solid at room temperature, except for there are some exceptions also. Like mercury is a metal that exists in liquid state at the room temperature, while majority of the metals exist at solid state in the room temperature. Here I have described that metals are described as chemical elements that readily lose valence electrons to form positive ions or cations. Let us understand what basically it means over here. Okay, now see, you might find it a bit confusing, but let us try to understand it in a simple manner. See, moments ago we learned about elements now, few minutes ago. Okay,
Yes, sir.
what are elements made up of? Elements are made up of atoms, right now?
Yes, sir.
Okay. See, earlier we believed that atoms are the smallest particle, they are indestructible. Atom is the most smallest particle. Earlier that's what was thought. But now we know that atoms are also divisible. Atoms are atoms are divisible, meaning that atom when you look inside the atom, there are going to be some subatomic particles. So subatomic particles like protons, neutrons, and electrons are found inside this. Have you heard of any of these? Like electron is the most common one. You might have heard of this while studying electricity.
Yes, sir.
So we study about subatomic particles, the particles that is smaller even than a atom, right now. So inside the atom, you will get to see that you will be, first of all, in the center, you will be having some particles that will be positively charged, while some of them will have no charge. Some of them are positively charged, some of them are not not having any charges. So the one that is having positive charge, they are called as photons, and the one that are having no charge, they are called as neutrons. What do we call them as? Neutron. Meaning that
Neutron.
they don't have any charge, no charge on them. While photons have positive charge.
Negative charge.
Now, there's one more subatomic particle that we know as electron. And electrons are negatively charged. They are going to be negatively charged. And electrons are negatively charged and they will be rotating around the nucleus. This photon and neutron is lying inside in the center now. They form the nucleus of the atom. Just like we studied that nucleus is found inside the cells now. Kind of a similar manner,
Yes,
understand?
sir.
The center is called as nucleus. This is the nucleus of the atom where photons and neutrons are found, while electrons are float if are is rotating, moving around the nucleus. Okay. Now, the most important thing. What happens that atoms are usually neutral. Atoms are usually neutral in a neutral state. What does it mean that? It means that usually when there is no when there is not any external disturbance, so thereby the number of protons and electrons remain same. Meaning that, say, for example, if you were to have one example, say talk about let's talk about sodium, for example, or let us talk about, let us just say we have got any atom. So in their neutral state, if they are having 10 protons, so they will also be having 10 electrons. Getting it? So
Yes, sir.
positive equals to negative. Positive charges and negative charges are equal. So in this situation, they are said to be in a neutral state. Is that much clear?
Yes, sir.
So atoms are usually in a neutral state, meaning that the number of positive and negative charges are equal on them. So we say that they are electrically neutral. Number of protons and electrons are equal. Now, what will happen now? If an atom loses, if an atom loses or gains electron, then they will become charged. Then they are going to become charged. See, one more thing you need to know, that protons and neutrons are fixed. Protons and neutrons, they are fixed. They can't move. They can't change their position. All right now. But what we know that electrons are free. They are free. They can move from one atom to another. Getting it? They can move from one atom to another. So let's take an example. For example, if you were to take a example of a sodium, the number of, where does sodium lie here? This is sodium. Okay, na? This is sodium over here.
Okay, sir.
Say you have this is the atom of sodium, for example. This is the center. Two atoms, two electrons are here. Then you have 2, 3, 4, 5, 6, 7, 8. Then there's one more. Okay. Say this is the atom of a sodium. All right. Now sodium has got how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, now it has how many electrons?
11.
11 electrons. But there's a rule which says that this is the first orbit. This is the first orbit of this atom. This is the second orbit. The rule says that you will be studying about it in the higher classes, but let me just give you a rough idea about this. The rule says that in the outermost shell of a given atom, only 6 electrons can exist, not more than that. But if there is more, if there is less than 6, then it will be losing. It will lose that. So this outermost orbit of this atom has got how many electrons? One, no?
Yes, sir.
But the rule says it should have how many?
6.
So it will be not six, I mean to say eight, by the way. It has
Yes,
eight now. Eight. So as per the rule, it should have 8 electrons in the outermost shell right now. But here it is having one. So it will lose it. Right? Okay. So before losing it, what was happening? What was the case with this atom? Before it lost this electron body, it had 10 protons and it had 11, I mean to say it had 11 protons and 11 electrons now.
Yes, sir.
After losing, what happened? Eleven proton and 11 electron. At that time, was it neutral?
Yes, sir.
Because number of electron and protons were equal. Now, after losing, what happened? Protons, their number is not going to increase or decrease. It always remains same. Okay.
Okay, sir.
But you tell me, is the number of electron increasing or decreasing?
Decreasing.
So that becomes
10.
10, no? 10 electron. Right now. So here you tell me, what is the net difference of the positive and negative charges here?
So,
There's
1.
one, no? So which one is extra? Positive or negative?
A positive.
Positive extra, no? So this, we see that it gains a positive charge. Right now, it gains a positive charge. And why it gained positive charge? Because it lost an electron, no?
Yes, sir.
Getting it? So the thing about the metals is that metals loses electrons to form to become positively charged, right now. And when an atom becomes charged, then it is called as ions. What do we call them as?
Ions.
Ions. So ions are basically what? They are charged atoms. And ions can be positive also, and they can be negative also,
Negative.
right? Okay. While when you will be studying about non-metals, there you will understand that atoms will become negatively charged. While in the case of metals, what is happening?
They are positive.
They're becoming positive charge. And here we have taken example of sodium. The symbol is capital and small a. From the periodic table also you can understand it clearly, that is it is shown
And
by the blue
and
color, no? Yeah, that is N in the symbol, and it is lying over here. And all these atoms are metals. These elements are metals now. While if you were to take example of sulfur or oxygen, so they will be gaining electron. Okay, now. So we
yes, sir.
can say one thing, that metals are, they become positive ions right now, or we can basically say that they lose electron. Are you getting it?
Yes, sir.
What can we say about non-metals?
They are positive electrons.
No, no,
Ions.
negative ions, no? And why it is happening?
Non-metals.
Because
Okay, okay.
non-metals, no? So
Okay.
they become negative ions, and they become negative ion because they gain electron
Gain.
right now. Very good. Okay, so that is the thing about the metals, that metals are described as chemical elements that loses electron. Forget about valence here. Loses electrons to form positive ions. Just keep this much in your mind. Okay, no?
Okay, sir.
Okay. You have several examples like aluminum, copper, iron, tin, and gold. Here it says around 90, but the exact figure is 93. Okay, no? So you can correct this to be 93. So out of 180, 93 of them are metals.
Metals.
So hope it is clear to you so far.
Yes, sir.
Let us understand what are the physical properties. What are the physical properties of metals? The physical properties of metals are as follows. Metals are going to be malleable. Metals are going to be, let us understand about its sonorous property. Okay, now. So metals are going to be sonorous, meaning that when they are struck, they will be producing a sound. When they are struck, they produce a sound. So, or basically we see that they makes a ringing sound when we strike them. A sonorous basically means that capable of producing a sound, something that is capable of not just a normal sound, but capable of producing a ringing sound. Like our vocal cord can also produce sound, but does it produces a ringing sound?
No, sir.
No. So we are talking about a particular kind of sound, that is a ringing sound. So if you drop a metal coin or a metal utensil on the floor of your house, what happens? It produces a ringing sound. Now, hope you are getting it. Okay, now. So metal sheets will be used to make bells. It will be used to make the ringing bells of the bicycles also, and in the temple bells also it is being used, as you can see in this image. Right. While we will be talking about non-metals, we will get to know that non-metals are not sonorous. Okay, now. So first property we learned that they are sonorous. Second property we are going to learn that they are malleable. So what does malleable mean? Basically, it's a property by which we get to see that they can be heated and they can be hammered into sheets. So it means that metals can be beaten into thin sheets with a hammer. If you were to take a piece of aluminum metal and place it on a block of iron and beat it with a hammer, you will find that the piece of aluminum metal will turn into a thin aluminum sheet without breaking. It's not like it will start to break apart. No, it will be simply its size will expand and it will convert into a sheet. So the property which allows the metals to be hammered into thin sheets, what do we call that as?
Malleability.
Right now. So upon hammering, they can be converted into thin sheets. Right. Most of the metals are malleable, and particularly we have the best examples as gold and silver. Gold and silver, they are the best malleable metal. Okay, now.
Yes, sir.
So hope you are getting it. Copper can also be hammered to form copper sheets. Right now. And iron is also a quite malleable metal, which can be hammered to form iron sheets. And it is due to the property of the malleability that metals can bend to form objects of different shapes by beating with a hammer. For example, it is because of the property of malleability of iron that an iron smith can change the shape of the block of a iron metal by hammering to make different iron objects. Like he can make out of iron, he can make an axe, or he can make a spade, or he can make a shovel. Right now. While when we get to learn about non-metals, they are not malleable. Right now, they cannot be beaten into thin sheets with a hammer. They will simply break into pieces upon beating with a hammer. Okay, now.
Yes, sir.
Now, if you were to talk about ductility, ductility basically means that it's the property which allows the metals to be drawn into wires. Right now, most of the metals are ductile, and again, gold and silver are the most ductile metals which you have. Okay. Copper and aluminum are also there. They are also very ductile and they can be drawn into copper wires or aluminum wires. And copper and aluminum wires, where do we use them?
And like electricity to make wires.
Exactly. They are used as electrical wires right now. And metals, later on you get to know that they are good conductors of electricity also. Right now. Further, we use iron wires also now. Iron wires are particularly used for making wire gauzes. Huh? Like you will see that in the prison wall iron mesh will be there, iron gauzes are going to be there, right now. Further, there's a metal called as tungsten. You know where it is used?
Yes, sir. In bulbs.
In bulbs, right now. So it is used in bulbs. So it is also drawn into wire, no? So that
Yes,
is
sir.
also there. So generally, so we can conclude that almost all the metals are ductile, except for which one? Like mercury is not a ductile metal, right now.
Yes, sir.
Then metals are good conductors of electricity. So talking about conductivity, not just electricity, you will get to know that they are good conductors of heat and
Heat.
electricity both, right? So like if you hold one end of a metal spoon, like you have an aluminum spoon, and you put it into the hot water, then its other end will also be becoming hot very soon. This is because metal conducts heat or carries heat from one place to another via the process of conduction, right now. Then we have several examples like copper, silver, gold, aluminum, and iron. All of them are good conductors of heat. They are good conductors of electricity also, right now. Like silver is also a good conductor. Then talking about this, you have copper, aluminum, right? And they are commonly used for making electrical wires. You can also learn about the property of this electrical conductivity property of metals by taking several samples of metals or non-metals, right now.
Yes,
Further,
sir.
let us understand about the physical properties of non-metals. So talking about the physical properties of non-metals, that they are non-lustrous, they are not hard, right now. They are brittle. Upon beaten with a upon hammering with a hammer, they will break into pieces. So non-metals are brittle in nature, meaning that they break into pieces upon hammering. You have examples of like coal. Huh? Coal gets broken
Yes, sir.
into pieces when it is hammered, right? Also, you need to know one more thing, like the coal which I'm talking about. Like it is basically made up of carbon, and carbon is what? Carbon is a non-metal. No? You have coal. Coal is made up of an element
Carbon.
that is called as carbon. And carbon in the periodic table, you get to know that it is a non-metal.
Non-metal.
And carbon is mainly found in many forms. Like it is found in the form of charcoal and what else? Graphite.
Yes, sir.
We learned about coke in the previous chapter. Coke.
Yes,
The
sir.
most common one is diamond also. Right? A diamond is also made up of carbon, by the way. Huh? All of them are made up of carbon, but yet all of them are very different from each other. Coal is also mainly carbon, basically. Pencil graphite is used where? It is used in the pencil lead, no? And
Yes,
pencil
sir.
lead. Graphite is also used as a dry lubricant, by the way. Dry lubricant because it has got very high melting point. That's why it can be used there. So if you were to take a piece of say graphite lead, a pencil lead basically, and beat it with a hammer, what will happen? It will break into pieces. Uh, So also we cannot hammer any kind of carbon to obtain thin sheets of it. It will simply break into pieces. So carbon is a non-metal and which is not malleable. So carbon is non
Non-metal.
also non-malleable. I'm saying non-metal and also it is going to be non-malleable. So we see that they are non-malleable also, right now. Further, you get to know that they are not lustrous. Usually, when we look at the metals, you can see all of them have got a luster now.
Yes, sir.
So metals are lustrous, meaning that They will reflect the light. They are good reflectors of light. When light falls upon them, a smooth reflection will usually take place from them. The thing why anything shines, because if it reflects the light rays, if the regular reflection of a beam of light takes place like this, this is a regular reflection. So due to
Yes,
this,
sir.
that object will be shiny. Well, when you look at a non-metal, you will get to know that the reflection that is going to take place from a non-metal, for example, it will take place in this direction. It might take place like this. It might take place like this. So although all the rays are coming parallel to each other, but they get refracted into random directions, not in a fixed or not in a particular direction. So that is irregular reflection. So apart from second property, apart from brittle, we get to know that they are non-malleable, meaning that they cannot be beaten into thin sheets. Further, they are non-lustrous. Do tell me, are they going to be ductile?
No, sir.
Obviously, no. They can't be drawn into wires now. So that is also true for them. So they are non-ductile. Okay, and are they strong? No. In terms
No,
of
sir.
strength, their tensile strength is very low. Right now, meaning that non-metals can't hold large weights. They are easily snapped. Huh? For example, say that you have again take example of this graphite lead, this pencil lead. So say you have a 1 meter pencil lead, for example. You have a lengthy pencil lead that is made up of carbon. That is basically graphite. On one end of it, let's say you have tied a piece of brick, and here you are holding it with your hand. You tell me what is going to happen.
Can you repeat?
It will. I'm saying that you have taken a 1 meter length of pencil lid, and one end of it is tied with a brick, and here you are holding it. Is this pencil lid going to hold it, or will it break?
Mm, it will break.
It will break now. While
Yes.
if here, for example, if you were to take a iron rod in place of this, so it was not going to break right now.
Yes, sir.
So further, we can see that non-metals have low strength. Non-metals have low
Yes,
strength,
strand.
right now. That's why in order to like construct bridges, we would be using iron metal, we would be using a steel, right now. So metals are usually strong. They have high tensile strength, meaning that tensile strength, by the way, means that the ability of the element to hold large weights without being breaking. So they have low strength, or basically low tensile strength. Is that much clear?
Yes, sir. So, but
Okay.
diamond is like strong.
Yeah, we have one exception over here. Very good. This is an exception here. Exception only in the case of brittleness and in the case of this lustrous. So they are not brittle, neither they are non-lustrous, meaning that they are lustrous right now. So
Yes,
they
sir.
are lustrous and they are not brittle in nature. Okay. And they have a strength also, although it's not in terms of tensile strength. Further, we get to talk about this property like sonorous. Will striking the diamond or will striking particularly this coal going to produce any sound?
No, sir.
No. So whenever you will be having a solid non-metal, although keep this one more thing in mind that usually most of the metals are in solid state. Almost all of them are in solid state. While talking about the metal non-metals are going to exist in the gaseous state. They are going to exist in the liquid state also. They're going to exist in the solid state as well. So if you were to drop a piece of charcoal on the ground, will it produce some sound?
No, sir.
It will be very less right now. So we say that they are also non-sonorous, meaning that they do not produce any sound right now. So they are not capable of producing particularly a ringing sound when they are struck. As we learned that metals are usually hard, but there are some exceptions in the case of metals also. Hmm? There's going to be one exception in the case of hardness. Do you know about sodium?
Yes, sir.
Sodium is a metal now,
Yes, sir.
but it can be cut with a knife. You know about this?
No, sir.
It is so soft that it can be cut with a knife right now, but not all of them. Most of them can't be cut easily, but you have one exception: sodium, cut easily with a
Sodium
knife.
and potassium.
Potassium also is there right now, and you can cut them with a pair of scissors also. But if you were to try to do the same for a piece of iron, it is not going to happen right now. Or but if you were to have a very thin sheet of aluminum metal, a thin sheet of aluminum metal can also be cut easily using scissors right now.
Yes,
A
sir.
thin sheet of that can be done. But what does it mean? That aluminum metal is less hard as compared to iron right now.
Yes, sir.
Okay. Sodium, apart from this, we should count this potassium also. Very good. Both of them can be cut using a knife also. Later on, while we're studying about chemical properties of metals, we will get to know that they are very explosive. Like if they are thrown into water, it will be a explosive reaction. Okay.
Yes, sir.
Oh, this one more, by the way, magnesium metal also, I forgot about this. Magnesium metal can also be cut easily. Not talking about it, saying that it can be cut with a knife, but it can be cut very easily. Okay, talking about hardness of non-metals, most of the solid non-metals are going to be soft. Here we are going to talk about solid non-metals. Right now, for example, you have in the beginning I showed you image of like this one, by the way. This sulfur. Sulfur is yellow in
Yes,
color,
sir.
by the way. So sulfur or phosphorus, they are non-metals which can be easily cut into pieces with a knife. They are, you can see, it looks like they can be easily cut down with a knife. But we have one exception, that is diamond right now. So
Yes, sir.
most non-metal, most solid non-metals are soft. Exception, you will count it as diamond. So hope you are getting it. So we have one question over here. State two reasons for believing that copper is a metal and sulfur is a non-metal. Do tell me. Answer this.
So copper, like it is malleable and good conductor of heat and electricity,
Very good.
and whereas sulfur is like not hard
Hmm.
and it is not like good conductor of heat and electricity. It is not malleable and it cannot like be blown into a wires or something.
Very good, Gauri. Okay, now here's the conclusion of the differences between the two. Right, the metals are malleable and ductile, while non-metals are neither malleable nor ductile. They are rather brittle. Metals are good conductors of heat and electricity, and non-metals are not. Exception is there, like graphite is going to be a good conductor of electricity. It can be used to conduct electricity. Metals are lustrous or shiny, although non-metals are not lustrous or shiny, but there are some exceptions, like you have diamond. Right? Metals are going to be strong, they have high tensile strength, except for obviously sodium and potassium are going to be exception because they are not strong and have low tensile strength. Well, non-metals are strong and they are not strong and they have a low tensile strength. They are sonorous, they are generally hard, while that is not seen in the case of non-metals. We have one exception in the case of hardness. You have diamond right now. Okay. By the way, you know that diamond is no longer the hardest substance on Earth. You know which is the hardest substance on Earth?
No, sir.
Yeah? Apart from diamond, there's one more which is there. Okay, now I believe that it is forgetting the name.
Nokia
I will
phone.
which not
Nokia.
Nokia phone. Jokingly, people say that, but that is actually not the case. You have some compounds which are much more stronger than that. Okay, now they are said to be like 15 or 20% stronger than the atom. Like you have a compound called as boron nitride, by the way, boron nitride. But it is made up of different type of atoms. Okay, now. But if someone asks, is there something that is stronger, that is harder than a diamond? So yes, we have this example, boron nitride. Okay.
Okay, sir.
Now we are going to learn about the chemical properties of the metals and non-metals, right? While we talk about chemical property, while we were talking about the physical properties, we were looking at the physical aspects only. Hmm? How they look, um, what is the state in which they exist. Hmm? Do they produce sound? Do they conduct electricity? Those were the physical aspects, right? Now let us understand about the chemical properties of metals and non-metals. So first of all, we are going to learn about metals. So in this, let me quickly tell you what are the things we are going to learn about. In this, we are going to learn about reaction with oxygen, how metals react with oxygen, how non-metals react with oxygen. Okay. Later on, we're going to learn about reaction of metals and non-metals with water, how they are going to react with water. Further, we are going to learn about their reaction with acids and bases. Okay, so let us start from metals. How metals are going to react with oxygen. So you might have seen or you might have observed that after some time, metallic objects tend to lose their luster. They tend to lose their luster. Hmm? Say what is going to happen. You have a metal, it would react with oxygen. Hmm? It will react with oxygen to form a metal oxide, right? A metal oxide is formed. Say, for example, you have a magnesium ribbon. You have a magnesium. You know, we talked about magnesium in the previous class also, where I told you that that it burns with a very dazzling flame.
Yes, sir.
I will look at this image, by the way. This is a magnesium ribbon, hmm, and it burns with giving a very good amount of heat and light. Particularly, light is given off. A very dazzling light is given off upon burning this.
So we
So what?
did this in our like class.
Oh, that's good. Right now. So what happens when magnesium burns in air? It combines with the oxygen of air to form magnesium oxide, as you can see in this image, right? And this particularly what is much more important is about the property of this metallic oxide that is formed. This magnesium oxide is a basic substance. It's basic oxide, meaning that it is having a basic property. Huh? So what happens? I can use this to check its if when we did the litmus paper. Now what happened? In order to do this litmus paper, water has to be added to it now. Huh?
Yes, sir.
Because litmus paper do not work on dry acids or dry water. Any uh, acid or water, which acid or base, if water is absent in it, so litmus paper is not going to work. So here what you have done, you have, for example, you have magnesium plus oxygen. There you had magnesium oxide. Now in magnesium oxide, you will add some water. Add some water to this. Thereby magnesium hydroxide is going to be formed. MgOH whole 2. That is magnesium hydroxide. So upon checking the upon doing the litmus test paper, what we learned that this magnesium hydroxide will turn which litmus into which color? It turns red litmus
Right.
to good. So if it turns the red litmus color to blue, this basically concludes that it's a basic substance. So thereby we can say that this magnesium oxide was actually basic in nature. So what we can basically say that metals upon reacting with oxygen gives a basic oxide. Can't we say that?
We can say that.
right now. So that is the first thing about it, right? So hope you have understood. Similarly, you can have several other examples also like that of sodium. Sodium is also a metal, and sodium will also react with oxygen. Upon reacting with oxygen, it forms sodium oxide. Again, sodium oxide is also going to be basic
Basic.
oxide now. It's going to be basic in nature. We have an activity here to show that iron oxide, basically rust, is also basic in nature. You know about rust, that
Yes, sir.
a layer of rust forms above iron articles.
Yes,
So
sir.
in this case, basically what happens, you have any iron object. It is going to react with oxygen. It is going to react with water also. Where does water come from? This water is basically going to come from damp air. Damp air basically means that in which high amount of moisture is found. So from there it is going to get water. From the other sources also it can get water. Right now. So oxygen and water it is going to get from a damp air, both of them. Now here what is going to happen? A reaction is going to take place between iron, oxygen and water, and it will lead to formation of iron oxide, which is basically rust. The formula is Fe2O3. That is your rust. Right now. So
Yes,
this is
sir.
one such example, and if you were to talk about its property, it is going to be basic in nature because since it is formed due to reaction between a metal and a and oxygen. Water is also there. So hope you are getting it. Okay, now
Yes, sir.
we have some more examples. You might have seen that pipes made up of copper or objects made up of copper, after some time they develop a green layer above it. Huh? So the question is, what is that green layer that forms above them? So that is also here also the same kind of reaction is going to happen, but this one more thing. What happens when a copper object is exposed to moist air for a very long period? Then copper starts to react with water, not just water. It also starts to react with carbon dioxide. Carbon dioxide, water, and carbon dioxide, and one more thing, oxygen also. As a result of this, it is going to form, I'm
Copper
writing here.
hydroxide.
Very good. It forms copper hydroxide. Apart from that, there's one more product form, that is
Copper carbonate.
copper carbonate. Right now. So a mixture of copper hydroxide and copper carbonate forms above the copper, and that basically gives you the green coating above the copper utensil. Hope you are getting it.
Yes, sir.
Right now. So whenever copper vessels would be exposed to moist air, after some time, after a long time, it acquires a green coating on its surface. That coating is basically made up of copper hydroxide and copper carbonate. Right? Okay. If you were to look at its property, again the property is going to be basic now. Right now. And also this deposit, this formation of green coating of copper carbonate particularly if you were to talk about which one is responsible for the green color, this copper carbonate is mainly responsible for giving it the green color. Furthermore, when you talk about its property, this is again going to be basic in nature. Right now, the formation of green coating of basic copper carbonate on the surface of copper objects on exposure to moist air, this is called as corrosion of copper. What do we call this as? Corrosion of
Corrosion
copper.
of copper.
And when iron will be rusting, that will be called as corrosion of iron. Okay. But once we get to know about the non-metals, we will learn about non-metals that upon reacting with oxygen, they will be forming a non-metallic oxide that is going to be acidic in nature. Later on, we will learn about that. Okay, now. So hope it is clear to you.
Yes,
Hope it
sir.
is clear to you. Okay, now. Now let us learn about sulfur. Do we have time left? Oh, we have passed the time, by the way. See, there's one more class that would be required to complete this chapter. Okay, now.
Okay, sir.
Today we learned about some of the basic things, and we learned about the physical properties of the metals. Right now, few more things are left to be discussed. Okay, hopefully that will be covered in the next chapter. Like a reaction of metal with water is left to be discussed. How it reacts with the acids and bases, that is left to be discussed.